All right, the last section in this unit, section 6.9, and this is on rotations. Rotations. So if we're looking at our vocab once again, make sure we get these two new vocab terms into your notes. And what we're trying to work on is how to graph rotations on a coordinate plane. And when we're talking about a rotation, what we mean is it's a transformation, so we just did that, involving turning or spinning of a figure around the center of rotation, which is a fixed point. So some point. So like you took a piece of paper. So let's take a look at this activity. And if you want to do the activity, you can. But I'm mostly just going to talk about it here. But let's take a look at what they've done. They drew this object on here. They drew this object there, and then they said, hey, let's change that piece of paper. Let's rotate it around that point. So think of them putting a pin in right there, and then they start to move the piece of paper from that pin. And so they've moved the paper and this at this angle here, and if they were to redraw it over here now, this is how that would look. So you get this object, which is the exact same object because all you did was move the paper, but it is now at a different place. That is known as a rotation. So that's what we're going to try to do. And when you do this, what you'll find is that all of these angles then are the same again if you did it correctly. Okay, so let's take a look at the key concept here. And so first thing they're talking about is that corresponding points are the same distance from R. In other words, if this is my center of rotation right here, to x, the distance to x, and the distance to x prime, those are going to be the same. That's why we have little tick marks there. The distance from here to y and y prime, or y prime and y, those are the same. So those distances are always the same. And then what else they say is that the angles formed by connecting R to corresponding points are congruent. So what exactly do they mean by that? Well, let's take a look. They're talking about, this is their statement, they're saying that the measure of angle XRX prime is the same as the measure of angle YRY prime. What do we mean here? So this is what we're talking about. The measure of angle XRX prime is something. Let's say that was 75 degrees. And then that is going to be the same as from Y, R, Y prime. That would also have to be 75 degrees. So in other words, every point has been rotated the exact same amount of degrees. That's what they're trying to get across there. And then the last thing they say, number 2 here, says the image is congruent to the original figure. All the orientations are the same. But what we've done is we've rotated it in space and around a particular point, and you need to be able to look at things and see, are these rotations and so on. This is there's a lot of stuff that we would do, like when you're designing things, you really have to work on those kind of things. So I know that Mr. Pollock in his class that he's teaching, his intro to engineering design, they would have to rotate points and things a lot of times when they're actually designing three-dimensional figures. All right, so let's take a look at an example here. Let's take a look at this example. And it says, graph triangle XYZ with vertices 2, 2, 4, 3, 3, 0. Then graph the image of triangle XYZ after a rotation of 90 degrees counterclockwise around the origin. So my origin is where I'm going to put my pin. That's where I'm rotating everything around. And so here's the directions. Here's how you would do this. Okay, first it says lightly draw a line connecting point X to the origin. So the first thing that I'm going to do is to draw a line. Let's go to a grid system here. So I'm going to draw a line lightly, and I'll just use a different color, to the origin, because that's my point. I'm spinning everything around, and I'm going to draw a line from there to X. Okay, so that's the first part of step 1. Then it says 2, lightly draw line 0 or OX prime so that the measure between x prime OX is 90 degrees and that they are the same length. So in other words, okay, so look at this. My length, it went from here through this corner, through that corner, right up there. I want to make a 90-degree angle right here, is what they're saying. So that's going to go here, here, and it's going to end up right there. So that is my new x prime. Okay, so let's make x prime. Let's put that in green. All right, so let's make x prime. And I really have no idea what that is doing here. Cancel that. I don't know if I hit GarageBand or what I did there. Okay. All right, so let's make all that green. Like I said, let's turn x prime green. So I made this angle, and you know you can usually figure out exactly what a 90 degree. They're going to do easy ones for you. They're going to be 90 degrees or 180 degrees or maybe 270, but they're all going to be those, you know, pretty normal translations that you'd have to do. So that's what you do. Then it says step 3 says repeat steps 1 and 2 for points y and z, and then erase all your lightly drawn lines and connect the vertices to form triangle x prime, y prime, z prime. All right, so let's see if we can do that. So now let's do y, and once again, let's actually, since we've got this one done, let's get rid of that here so that doesn't confuse us. I can erase this without killing everything else here. Okay, so now the next one I'm going to do is I'm going to start at the origin, and I'm going to draw a straight line out to y. And I need to create a 90-degree angle that is going to give me the same thing, and draw that line here. And that would end up right there. And of course, I told you. Okay, so there's my problem. I keep bumping the button here. So I want to turn this green. And this is going to be my y prime. And then with z, well, let's get rid of that red line now. Not doing very well here. I'm going to have to leave that part in there. I don't think I can get rid of that. All right, let's put my dot back for y prime. And then for z, I'm going to draw a line here, straight out, and 90 degrees. Now this seems a little confusing, but 90 degrees is really easy. It's straight up, okay? So I want to go up here. So that's where I'm going. And here is my z prime. And now I want to redraw my triangle. And what we want to make sure happened here is that point y rotated there, point x here, and z here, and they all, you know, that whole thing just rotated around this point right here, the origin in the middle. And it just takes a little practice. You got to look at this and kind of visualize, did these things turn correctly? Let's take a look at the last part of what they talk about here, and you're going to see, you know, kind of maybe some use for this. I know if you're making, you know, a design like they're talking about those barn signs, and you know we see some of those. I think if you go up towards Jefferson, you see some of those barn signs, and it says copy and complete the barn sign shown so that the completed figure has rotational symmetry with 90, 180, 270, and that's pretty easy. That just means we're going to take this and we're going to rotate it, you know, 90 degrees. So the first rotation is going to be here, 90 degrees. And so you're going to take this point and it's going up to here, and the point that was here is kind of going down to there. And then we just continue that here and then here, and you complete your pattern, and you have this nice design that you've created. And really, you started with one sequence or series of points here, and then you finished that rotation out and you created that. And so what we're going to do now in here is you're going to get to do some of these rotations. Now, if if doing those rotations, if you want to use a protractor to help you figure out your angles, you certainly can. A lot of times you can figure it out from the graph itself, but if that's confusing, then just get one of the protractors and figure out exactly what 90 degrees is or 180 degrees is and so on. And several of them are just, you got to look at the pictures and decide, hey, does this is this actually a rotation? If I were to think in 3-dimension, or not 3-dimension, but if I were to think about rotating that, would it match up with that after 90 degrees or 180 degrees or whatever? So that's kind of the idea of what you're trying to figure out here. This is a lot of visualization, I guess. You got to think in your head of, does this exactly look like that when it's all said and done?